Hi, this is Marissa, and I just wanted to put together a quick video to walk you through the basics of pointers in C. And so for this, I'm assuming that you have a little bit of Java background because I'll be referencing some things from Java. So first, I'm going to start off explaining what exactly is a pointer. Then we'll move on to how memory works, because to understand pointers, it's important to have at least a high-level understanding of memory. And finally, once we know how pointers work and how memory works, we're going to see how we can actually use pointers in C. First, what is a pointer? So pointer is just a variable that stores the address of another variable, the address being wherever it is stored in memory. So if you recall from Java, we had reference variables when we were talking about objects. So for example, if I had some class dog, and I wanted to create an instance of a dog, the first thing I would do is declare a variable of type dog. Now what this does is it sets up a slot, a variable in memory for dog. And to start off, we can say that that variable doesn't point to anything. The value is null, meaning there's no dog in existence. We just have something set up that will point to the dog when it is created. Okay, so again, in Java, when we instantiate our variable, we say dog equals new dog, and in this case, pass in their name and age. What happens is Java goes and it gets some memory and it actually creates an instance of the dog class, and that dog is somewhere in memory. And then once that dog is created and we've assigned it to our dog variable, we can say that dog references that object in memory. And really what that's doing is it's storing the address of that dog object. So if it's in slot 1, 2, 3, 4, then dog just holds that address, which is 1, 2, 3, 4. Now, it's important to realize that it doesn't really matter what we're pointing to. Pointers always store the address of whatever object is stored in memory. So for example, if I have a character A that happens to be at memory position 0x00012, that pointer, this arbitrary char pointer, stores that address 0x00012. Same thing if I have an integer, whatever that address is of that integer, if I set up a pointer that points to that integer, that pointer is going to hold that address. Even if it's a string or an array of characters, whatever the first character of that string is the address of that string in memory. So our string pointer, again, will just store the address of that in memory. Finally, we can also have pointers that point to nothing. So a pointer can hold an address or the value null, which means it points to nothing, which in most systems happens to be address 0. All right, so now that we have a general idea what a pointer is, let's talk about how memory works. And I really want to emphasize that this is a super high-level introduction. There's a lot more details that we can talk about later, but this is just to get you going. So memory can be thought of as an array of bytes. It's actually really just a bunch of bits stored, but most machines are byte addressable, meaning we can only access data at the byte level, so in byte-sized chunks. Okay, so this is an example of a small, tiny chunk in memory. The address starts at 0x04, and it grows up and really just keeps growing up until the maximum memory address possible. And one thing to point out here, like I said, this is high level. These addresses are hypothetical. They're only going to be able to access certain address ranges, but we can just assume for now that we have this small chunk of memory, which is just a bunch of bits. Okay, so like I said, 1 byte is 8 bits of memory, and in all these examples, we're going to be working at the byte level. All right, so let's look at what happens when we want to store data in memory. So if I declare a variable char c equals the character A, we know that a character is 1 byte. So what happens when I declare and initialize this variable? My program goes and allocates memory to store A. So we have seen this drawing before, and you may have seen something like this. I have a variable C, and there's this arbitrary box, and it holds the character A. But what's really happening is somewhere inside of our large memory array, our program goes and it finds space wherever there's a slot available to store a character. It goes and says, oh, here, this looks like a good slot. So it says, this is my space. I'm going to set all the bits in there that are relevant to my A. So that is the ASCII representation of an A. And then it knows that C now is stored in address 0x09. So we can tie that address to that variable. And now we have A stored in that memory slot. Okay, just to do another quick example, the same thing is going to happen if we initialize a variable x. If I have int x equals 7, that's going to take up 4 bytes on this hypothetical system. I'm assuming that my integers are 4 bytes. So we can draw a little high-level box. We say we have a variable x and it stores 7. And again, what's really happening is that my program is going to request enough memory to store an integer. It goes and finds that slot. And once it finds that slot, it'll set all the bits in that memory that represent 7. And now the address of the first byte of that integer is going to be the address of my integer. So in this case, it's 0x04. And now we can just say that 7 is stored in address 0x04. All right, and on that same note, let's talk about how we actually store pointers in memory. Because remember, pointers are just another variable type. So here we're starting with that same example. I have my character C and my character variable C, which contains the letter A, and that's at address 0x09. Okay. Now I'm going to set up a character pointer. So we're going to have a pointer to a character. And if we want this to point to C, then remember, our pointer variable is going to store the address of C, which in this case happens to be 0x09. And this is the point I want to make, is that even though it is a pointer, that address still has to be stored in memory somewhere, just like any other integer or character or string. So that pointer, in this case, 0x09, might be stored in address 4. So the address is stored in memory at another address. And once we have that set up, we can then say that C pointer, which is stored in address 4, holds the address of C, which means that it points to C. So how do we create a pointer in C? There's going to be 2 operators that we're going to be concerned with. The first is going to be the dereferencing operator, or the asterisk. And this operator is what's going to give us access to the data that a pointer points to. We'll talk about that more in a second. Now, there's 2 uses for this operator. The first one is that we're going to use it to declare our pointer variables. So first, if I want to set up a pointer variable, let's say C pointer, that points to a character, I'm going to use the syntax like this. I say char star C pointer. And for this, I actually like to read it backwards. I say that I have a variable C pointer, and wherever I see the star, I think in my head it points to. So you're replacing that kind of with English. So I have a variable C pointer that points to HR. Another example, if I want a pointer that points to an integer in memory, I can write int star x pointer. And reading it backwards, I say x pointer points to init. The second operator that we're going to use is the address operator. And this is important because this is what will give us the address of any data that is stored in memory. If we have a variable, we can ask that variable for its address. So let's look at this setup right here. If I have my character C and it equals A, then I can create a char star C pointer like we saw in the last slide. So I have C pointer points to a char, and I can say now that that pointer equals the address of the character C. So after those two statements, I say that C pointer now points to C. And the same thing with my integer x. I create my integer x, and I say that I have x pointer points to an int, and I assign the address of x. So ampersand x is the address. And I remember that because ampersand starts with an A, and so does address. So the address of x is assigned into x pointer, which is a pointer to init. So x pointer points to x. Let's see if we can visualize this a little bit better. So if I want to set up a pointer to my character C that we've seen before, I already have my character stored in address 0x09. So if I want to create a pointer to that character in memory, I have to say char star C pointer, which means C pointer points to a char. And what that's going to do is set aside a slot to store a pointer variable or an address. And in order to put the address of A into that variable, as we saw before, we need to say that C pointer equals the address of C. So when I say address of C, it goes and finds that variable in memory and says, oh, I see that you're at address 0x09. Now we put that address into our C pointer variable. And now we can say that C pointer points to C. All right, that's our basic setup. It'll get more complex as we go, but that's all I want you to worry about for now. So once we have this pointer relationship set up, how can we use this? We're going to see our dereferencing operator again. So the dereferencing operator, remember, gives access to the data that a pointer points to. I said that there were two uses. The first that we talked about was using it to actually declare a pointer variable. So we need to say that it is an int pointer. The second use is once we have a pointer set up, we need to get the value of the data pointed to by a pointer. Okay. So what I mean here is that if I store the address of C into my C pointer variable, remember I can say C pointer points to C at this point. If I want to now get whatever C pointer is pointing to, which in this case happens to be C, I can say star C pointer. And in my head, I usually just replace that star in this instance with value of. So on the right-hand side, I say the value of C pointer. And then I store that into my character D. Again, let's see if we can visualize this a little better so you have a better idea of what I'm talking about. So leaving off on this setup that we saw before, where we have our C pointer that points to C, first thing I can do is if I want to store C pointer into my character D, I can try to say char D equals C pointer. And what that is going to do is it's actually going to go find C pointer and say, oh, C pointer, you're storing 0x09. I want to store your value into my character D. Unfortunately, this does not work. We're trying to put an address into a slot that's big enough to hold a character. And I wanted to show you that because that's a common mistake. What we really want to do is we want to say character D equals the value of C pointer, or star C pointer. So when we see the star, what happens is if we have C pointer, we follow that pointer with the star. So the star means go and follow what that's pointing to, grab the value of that variable, in this case it's the character A, and now that is what we're going to store into D. So we've said that the character D equals whatever C pointer is pointing to. Finally, let's look at another example. If we have an integer x equals 1 and another integer y equals 2, those are both stored in memory at some arbitrary addresses, and then we want to set up a pointer that points to an integer. So it's going to eventually point to either x or y. When I declare this pointer, because we haven't initialized it, that means that the value stored in IP is just whatever happened to be in memory before. So it could be pointing to nothing. It can be pointing to something we don't want to be pointing to. So the point I want to make here is if I have a third line in my code here, let's say I decide that I want to create an integer z and I want to store whatever IP is pointing to into z. First thing I have to do is dereference IP. So I say the value of IP, or star IP. If I use my star operator and go and find this possibly existent place in memory, that's going to give me tons of problems, because if I try and find the value of something that doesn't exist, I'm going to get an error. So my point here before I move on is don't try to dereference an uninitialized pointer. Always make sure that your pointer is pointing to something before you try to get its value. Okay, so taking a step back from that side note, let's look at kind of some steps we can do here. First thing we want to do is actually set up our pointer correctly. So we've declared our pointer. Now we want to say IP equals the address of x. So if we copy the address of x into IP, which is 0xF4, we've set up this pointer. So now IP points to x. One thing I can do is, now that I have that pointer initialized, I can use star IP anywhere that I would have used x. Because IP points to x, star IP is an alias for x. So if I want to say y equals star IP, I use my dereferencing operator star, go find the value at the end of that pointer, which is 1, and now I'm going to store that into y. We can also use the value of, or the star IP, on the left-hand side of an expression. In this case, we're going to say find the value of IP, which happens to be x, so follow that through, and store 10 in that value. So the same process. Always, the star always means find the value of that pointer. And we can use that on the left-hand side and the right-hand side. So here I'm saying go find the value stored at IP, which is 10, add 1 to it, 11, and assign it back to the value of IP, which is that x slot. So we're putting 11 back in there. It's the exact same thing as saying x equals x plus 1. That's it for this video. So in summary, a pointer is just a variable that stores the address of an object in memory. In C, we can use the ampersand or the address of operator to get the address of an object in memory. We can use the dereferencing operator to get the value that a pointer points to. We also use the dereferencing operator when we declare our variables so that we know that they are of type pointer. In following videos, I'm going to walk you through what it means when we pass pointers as function arguments and how that works. So we'll talk about pass by value versus pass by reference. And we'll also hopefully have a video talking about pointers and arrays and how the two are related. So hopefully you enjoyed this. Hope it helped. Leave me some feedback so I know. Otherwise, see you in class.